and good day to everybody. Yes, as Ringo has already said, we're here today in this webinar to talk to you about extracting the maximum value from the bearing from the day you purchase it to the day you dismount and replace it. My name, as I said already, is David Oliver. I have over 40 years experience in the bearing industry, many of those years spent working with customers and sort of being on the front line, working with machines, with those customers in most cases as well. So without further ado, we'll begin the presentation today and take you through the various facets which we sort of have put together relating to the life cycle of a bearing. We'll start off with the actual purchasing of the bearing, the buying of the bearing, and you might say, well, that's a very straightforward operation. We go to a distributor, we tell them the bearing we want, and we purchase it. But today, that is fraught with some difficulties, as some of you might well understand, because we have many issues across our range of products with counterfeit. And we want to draw your attention to this because it's important in terms of the performance of products and what you will achieve by the application of SKF products. People ask us, how large is the market? Well, it's an illegal activity, so it's very difficult to define the size of the market. However, estimates as much as a few years ago indicate that 20–25% of bearings in China, for example, in retail are counterfeit. We believe the situation may well be slightly worse in, for example, India. And around about 20% of all products sold as SKF in the Middle East, for example, are also likely counterfeit. So what is the impact of this? And I have just a small case to present to you today. In the UK, authorities in the UK with SKF raided a non-authorised SKF bearing distributor and seized around 1 tonne of counterfeit SKF bearings. And the background to this, how did we identify that this particular distributor was selling counterfeit bearings? Well, we were approached by an individual, a member of the public, who had purchased a bearing from this particular non-authorised distributor to put and fit onto his mountain bike. And he was so disappointed by the performance and quality of the bearing that he came directly to SKF complaining that the bearing wasn't fit for purpose, wasn't of good quality. And on further investigation, we obviously identified that the bearing was counterfeit. So that then led us back to the non-authorised distributor and the raid that was made. So this distributor cooperated fully. We seized around 1 tonne on the day, and he advised he had a further 1.5 tonnes of product which were en route to him. So in this particular instance, the product went to a guy that was riding a mountain bike, but it could have gone to you to be used in a critical piece of machinery. It could have gone to a repairer where it could have been used in a truck or a movable piece of equipment. And obviously that represents significant issues and danger to the general public and to you from a reliability perspective as well. So point to you would be to always use SKF authorised distributors. And if you're not using SKF authorised distributors, to ensure that the person you're buying the product from has a route to an authorised SKF distributor. So this is the first area of managing the life cycle of the bearing. When you buy a bearing, please remember that you're buying a very high precision piece of equipment. So when you receive it, ensure that the packaging is undamaged. If you are storing it, make sure it's stored in a dry area, having a constant temperature, to not mount and store the product against cold walls or directly onto a cold floor, not adjacent to heating pipes or even in direct sunlight. If you are looking to remove the anti-corrosive film on the bearing, try not to use chemicals to do that because they are by nature solvents and might well affect the lubricant that you duly apply to the bearing. If you are storing it for long periods of time, the box should be stored flat, not on end. Larger bearings, thinner section bearings can easily distort under their own weight, so they should be laid flat on any racking. After cleaning, if you're not immediately using the bearing, you need to further protect it against corrosion. And finally, make sure that the product is stored in a vibration-free area to avoid issues later on if the bearing is to be stored for an extended period of time. After purchasing the bearing, obviously the next step when removing it from storage is the mounting of the bearing. The mounting of the bearing is very important to consider. It's the reason for over 16% of all premature bearing failures, according to SKF statistics. And the message to you as an audience today is that almost all of these instances are preventable by the use of best practice and the use of the correct tools. And we'll give you some small insights into what that might look like during this material today. The mounting procedure can be done cold, often mechanically. It can be done through the application of heat and sometimes with the use of oil power, hydraulic oil, to facilitate and reduce the mounting forces during the process. Typically, bearings are mounted directly onto a cylindrical bearing seating. If that's cold, then the appropriate fitting tools should be used. And if the application of heat, then good quality SKF induction heaters would be the preferred equipment of choice there. Sometimes bearings are mounted onto a tapered seating. So this can be directly onto a tapered shaft or onto a variety of sleeves having a tapered outside diameter. So these can be done cold using mechanical fitting tools or sometimes hydraulically. And we would draw your attention to the SKF Drive-up Method when using hydraulics, and we'll touch on this during the next few slides. The consequences of the various types of mounting, if you're mounting directly onto a cylindrical seating, it's quite simple because everything is ready for you to mount the bearing. The shaft is prepared, the housing is prepared, etc. There's no need for additional measurements in terms of the mounting process. So there's no need necessarily to measure anything on the bearing during the mounting process. Disadvantages, you can't control the clearance in the bearing. That is dictated largely by the shaft tolerancing, so it's very dependent on tolerances. It's not possible to fine-tune the mounting procedure, so to adjust further the clearance in the bearing during the mounting procedure. Dismounting can be difficult because quite often the fits, particularly on a shaft, will be quite tight. And for very large bearings, hot mounting is impractical simply because of the physical size of the bearing, and mechanical mounting requires quite high forces to be used. On a tapered seating, the advantage are it's relatively fast and relatively easy to mount and dismount. Quite often we can use hydraulics, which simplify and ease the process. The method can be very controlled. We can get accurate interference feet or clamping forces of split sleeves on the shaft. We can fine-tune the process. We can adjust the clearance in the bearing to maybe take a little more clearance out or add a little bit more clearance in. It facilitates the use of sleeves. The use of sleeves can often prevent shaft damage should there be a bearing problem because they're quite soft in terms of the material, and it will convert a cylindrical shaft to a tapered seating as well. Disadvantages are that the mounting process can be complex and requires some experience. Measurements will be required. And if you are mounting the bearing directly onto a tapered shaft, the tapered shaft will inevitably cost much more to actually produce. For the cold mounting of bearing, the correct cold mounting of bearing, there are SKF fitting toolkits available to use. The reason that we prescribe these is that if you apply force to the incorrect ring during the mounting procedure, so to the outer ring if you're mounting the inner ring onto a tight shaft fit, or through the inner ring if you're mounting the outer ring into a tight housing fit, all of the considerable mounting forces will be transmitted from ring to ring through the rolling elements, inevitably causing bearing damage. If you use the correct SKF mounting kits, then those forces are applied equally over inner and outer rings, distributing the mounting forces across both, and that will reduce damage. Additionally, the impact rings in the kit marry up exactly with the bore and OD of ISO dimension bearings. There is a sleeve for different shaft lengths and different impact rings, and there is a dead blow hammer for safety purposes in the kits as well. Induction heaters are the preferred method of choice for applying heat to the bearing, and SKF induction heaters are of innovative design, so easy to use, easy to handle. They have fast heating and low energy consumption, so enhanced electronics. They are portable for the smaller sizes, foldable arms to support large diameter bearings, different yokes with storage for the yokes in the smaller units, and even smaller portable units are available now as well. All will have remote control with LED display, where remotely portable and integrated carrying handle and a magnetic temperature probe to prevent bearing overheating. There is a supporting chart to select the induction heater that might be required. There's also an online tool for heater selection as well. So on the vertical axis here, you see the outside diameter of the bearing, and on the horizontal axis, the weight of the bearing. So depending on the size and the weight, it will dictate which induction heater is required. The image to the right-hand side here shows you the latest introduction to the SKF induction heater range, which is the truly portable induction heater, TWIM1515. And this, as I say, can be taken to the job. It can be 110 or 230 volts. It will take a bearing weight up to 20 kilograms or 44 pounds with an outside diameter of 320 millimeters or just over 12 inches. So it will take a wide range of bearings. We'll be able to heat a wide range of bearings and can be taken to the job to do the heating process. What we'll be trying to avoid in the use of induction heaters, well, we want to have customers avoid or users avoid using open flames, so almost impossible to control the heat in such instances and almost certainly cause localized damage to the bearing. The use of oil baths, which have a health and safety issue, very hot oil being used. Quite often the oil isn't clean, so it's very, very dirty as well. And the temperature in those also is not often controlled. Ovens, again, temperature control, very, very difficult in ovens. Fume extraction, not always there as well. So much the best way and the optimum way is by the use of SKF induction heaters. If we use incorrect methods, if we apply these mounting forces across the ring as described in previous slides, you will see highlighted in red here indentations where the rolling elements have been jammed against the raceway groove of this double row bearing. If this bearing were to be further used, to be mounted and used in application, then the image to the right here shows you typically how the damage might propagate. So rough, uneven, noisy operation would be as a minimum that you would find, but inevitable premature bearing failure would be the end result of the indentations generated by a faulty mounting procedure. When mounting bearings onto a tapered shaft or onto a sleeve, we would recommend to consider using the SKF Drive-up Method. This is unique to SKF and actually features the use of critically two pieces of information which are published by SKF for each bearing. So it would involve the use of a hydraulic nut, a hydraulic pump, and an SKF pressure gauge, which is very accurate to low pressure. The reason it needs to be very accurate to low pressure is that the initial published pressure is very, very low to properly seat the bearing onto its sleeve or onto the shaft. And that is the start position for the drive-up technique. SKF hydraulic nuts are drilled through so that the dial test indicator can be located directly against the piston on the hydraulic nut. So the drive-up distance can be very, very accurately measured. And the drive-up distance is also published for each bearing by SKF. So it provides an accurate and reliable location method, very safe to use, and eliminates the quite subjective use of feeler gauges in the mounting procedure and the measurement of the reduction in clearance when typically mounting these bearings. And this is just a small case study from a customer in the food and beverage industry. These are flour milling devices. This particular customer had multiples of these throughout the facility. He was having to do frequent bearing changes due to roll regrinds. The mounting procedure, as described, was difficult, requiring some skill and experience. And in this particular facility, they only had one person that could do this mounting procedure. They typically had poor repeatability of the mounting and generally, because it was one person, lacked the requisite skills. So we talked to this customer about the use of SKF Explorer spherical roller bearings and introduced the hydraulic mounting drive-up technique. And what the customer immediately saw was improved reliability in his mounted bearings, much better accuracy and repeatability of the bearing mounting. He significantly reduced the amount of time it took to mount each bearing as well, which was a big saving for him. And he was able to use a documented mounting procedure using published SKF data. And that documented mounting procedure could be used by many technicians across the organisation, not just one skilled technician. So a big cost saving and benefit to this particular customer, and hopefully illustrative of the benefit of this technology. We now move on to the lubrication of the bearing. And again, this is important because over a third of all premature bearing failures are down to poor lubrication. We see issues due to incorrect re-lubrication intervals, which generates undergreasing or overgreasing. We see incorrect bearing selection, the use of poor quality lubricants or a lubricant type that is unsuitable for the parameters of the application. We see the potential introduction of contaminants, so impurities, whether liquid or solid, can mix with the lubricant, impairing its function. And poor handling can easily introduce dirt or grease during the mounting procedure for bearings as well. Lubrication is about many things, but some of the key ones are having the right grease applied in the right quantity via the correct method, which will protect the bearing and protect the process. So we see, as we've highlighted already, people making the wrong lubricant choice. If people use the wrong lubricant, it introduces problems, and when people see problems, they lubricate more, which exacerbates the problem. The wrong filling degree, so they put too much grease in the bearing or in the space surrounding the bearing. That leads to churning, extra friction, heat generation, and again, that leads to a more rapid deterioration of the grease in the bearing, prompting potential early failure. Overgreasing is problematic, particularly for high-speed applications, and again, down to internal heat generation. So the use of the correct grease with the correct tools is very, very important. SKF have a range of bearing greases which are designed to be suitable for particular conditions and particular operating parameters. It's a high-quality grease for bearing lubrication. It's of consistent quality. There's a complete product program for both general and very specific bearing lubrication requirements. A lot of international testing of bearing greases are done on proprietary SKF equipment anyway. So all of SKF greases are tested for specific functions and meet international standards for their use as well. Worldwide availability through SKF Direct and through the SKF Authorized Distribution Network, and available in a range of different pack sizes as well. Often re-lubrication has to be done manually, sometimes by hand, but again we would advise and urge the use of the right equipment and the right lubricants, the right quality lubricants in this procedure. Many different grease pumps can be used which add value. You can use a method for actually controlling the amount of grease that's used, that's discharged from a grease gun, for example. If you're lubricating large bearings, there are battery operated grease guns which can deliver larger volumes of grease very, very quickly as well. So be mindful of the requirements for manual re-lubrication and the items of kit that will be available to support you in that process as well. We often recommend the use of automatic re-lubrication processes. You see a range of products here, from simple gas initiated systems to electromechanical ones to multiple point systems. There's a lot of support available in terms of online calculation systems, so desktop systems and app-based systems, to enable you with the input of simple parameters to identify what setting to use for an automatic lubricator or what flow rates to use if you're having to do a wider re-lubrication of sort of more open bearings. What are the advantages of automatic lubrication? Well, it significantly actually controls and minimises the amount of grease consumption. It reduces leakage and spillage. It reduces contamination risk. It takes away many of the areas where human error can become a problem, and through all of these will limit and reduce the number of failures of products seen. The optimum way to lubricate a bearing is little and often, but practically speaking, if you're doing it manually, that's very, very difficult to achieve. So often, as demonstrated by the red line in the image to the top right corner of this slide, shows that by manual lubrication, we over-lubricate, but not frequently enough. So by the time we re-lubricate, the bearing doesn't have enough grease there. By the use of automatic lubrication, illustrated by the blue line, we're able to re-lubricate frequently with small amounts of lubricant. And that will optimize bearing performance, will manage quantities and the frequency of re-lubrication, will guarantee accuracy, improve safety, and reduce the amount of time that's taken in the re-lubrication process as well, saving in cost. We're also now starting to introduce, for our customers that have a service contract, wirelessly monitored automatic lubricators. So these are very simple to set up and install, will further increase personal safety, will facilitate the remote monitoring of the lubricator status, and are very flexible and scalable in terms of an overall lubrication solution. Without going into a lot of detail, the automatic lubricator will be connected through a gateway to SKF Cloud, and then that can be accessed through an interface or a lubricator control panel, which will give the operator information on the condition of the lubricator, the fill of the lubricator, whether it needs to be changed, etc. So from a remote desk, the whole system of automatic lubricators can be managed. This is a recent addition to the range. And the consequences of over-greasing, we see it all the time. Anybody that's involved in maintenance, that has access to machinery, that is involved in the re-lubrication process, will have seen images such as the one that you see here in front of you, where this particular set of shaft bearings on shafts was lubricated via a bunch of grease nipples on a panel, so the bearings couldn't be seen by the re-lubricating technician. So over-lubrication was a big problem here, and the condition of the grease was a big problem in this particular facility as well. So this is the potential consequence, and reliability is clearly the end consequence of this, or poor reliability. If you have a lubrication issue in a bearing, we typically see a very high glaze on a raceway surface, and that's because the damage is very, very localized in the first instance to the surface of the material, what we call fine-grained spalling or almost a polishing of the surface. The cage tends to suffer, particularly metal cages, very, very early in the process, because they do rely on a good lubricant to protect the cage surface from contact with the rolling element. So if there's poor lubricant, we often see wear, particularly in metallic cages. But ultimately, this will progress, as in the slides to the left-hand side, from the glazing and polishing through to a more advanced failure over a relatively short period of time if the lubricant is imperfect in any way. So we now want to look at alignments. We look at fatigue as a failure mode for bearings, and again, over a third of premature bearing failures can be associated to fatigue or high load or excessive load. Statistics tell us that around 50% of all costs related to breakdowns of machines with rotating shafts are caused by misalignment. We see different types of misalignment: parallel, where the shafts are out of line to each other, or angular, where the shafts are misaligned to each other in shaft-to-shaft installations. The consequences of that are obviously failure, unplanned machine stops, which are caused by excessive wear on things like couplings, pulleys, belts, etc. They will introduce extra friction, which is obviously energy. You will have high vibrations, higher noise. It will impact bearing life. It will impact other component life around the bearing as well. And as said, result in unplanned machine stops. Typical alignment processes that we see straight edges or by eye. This is very, very inaccurate, but very quick to do, very easy to do. We see more sophisticated methods by the use of clocks. So this can be very accurate, but is actually very, very slow process and very difficult to do, requires some training, some experience. But the use of laser shaft alignment equipment is typically relatively quick to do, relatively easy to do, and very, very accurate. So formal SKF laser shaft alignment equipment should be considered where you have shaft-to-shaft equipment. There are many, or several products within the range of SKF shaft alignment tools, from the simple foam app-based systems through to more sophisticated multiple shaft systems. And the selection of these really depends on need. But as can be seen in these slides, there are many different types of alignment process. I would also add at this point that many of these are supported by YouTube videos which illustrate the use of them, but the app will guide you very easily through the process, very user-friendly. Free apps available to download where there's not a tablet supplied with the mounting equipment. Just a simple practical example: if you have a 10 kilowatt motor, and if we have an energy cost of 0.1 currency units per kilowatt hour, you know, the cost of that one motor will be getting on for 9,000 currency units per year. As a conservative estimate, misalignment can certainly introduce a 5% energy increase. That will result in approaching 450 currency units per year. And if you have 10 motors operating, you've immediately got, without any consideration of reliability of the units, you have approaching 4,500 currency units per year as a pure energy cost if misalignment is not good in these applications. What the output of the misalignment of the laser alignment process will be is to tell you what shims are needed or what elevation is needed at various motor foot points and pump foot points, etc. The use of pre-machined shims are very helpful in this process to avoid the practicality of having to cut shims locally to the mounting job. There's a range of SKF Machinery Shim kits available to you, which are very practical and very helpful in this particular process. We should also consider belt alignment, because this also introduces problems. We see vertical misalignment, horizontal, out of parallel, and it's very simple to get the correct alignment equipment. So SKF have 3 simple belt alignment tools, very easy to use, very practical to use. 2 face-mounted units for different ranges, different pulley centres, and then a system for up to 6 meters where the laser alignment equipment actually fits into the pulley groove. So you get groove to groove alignment. So incredibly accurate pulley alignment with these belt alignment tools. Just a couple of case studies where we have customers. So in a shaft to shaft system, a customer was seeing high vibration. That was identified with some condition monitoring work with SKF as being due to misalignment, and it was resulting in poor reliability and bearing and coupling issues. So this was corrected, and that introduced a number of benefits: reduced noise, reduced vibration, reduced temperature, but an energy saving, which the customer calculated to over €1,000 a year in this particular installation. This was a customer that had multiple blowers in a food production facility. We're seeing very high energy consumption, which was with some analysis work done, some condition monitoring work done, was identified as misalignment of the pulleys. So after the simple realignment, there was an avoidance of equipment breakdown, there was an avoidance of unplanned shutdown, and for each blower, a saving of €850 per year. So you can see some before and after measurements on this slide taken in terms of amp drawage from motors as well. Then we come to basic condition monitoring. It's very important to understand the condition of your bearing, of your asset throughout its life, so you can best manage any things that are starting to change in terms of the signature of the machine. And some people still have a run to failure strategy. You know, that they're happy to see assets run until they fail and they change them. Some people move to more preventative, perhaps time-based maintenance, where they try and change product before they think that it will fail. But much the best way and the most effective maintenance strategy is predictive maintenance. So where you're trying to identify changes in the machine over its life, so you can react very early to condition, to changes in condition, to deterioration of maybe the bearings in a machine. There are many ways of doing that, of identifying changes in condition or the actual condition of a machine. So we can do it by temperature, via speed, via noise, via light flashes through stroboscopes, through detection of sound, visual elements through endoscopes, oil checks, cleanliness, electrical current measurements. We see a lot of issues with current discharge now with the use of speed control in electrical motors. Stroboscopes, this is a recently improved range from SKF. We believe that this is probably one of the most underutilised condition monitoring devices used on machinery. You can effectively freeze a rotating piece of kit, whether that be maybe a chain drive, a pulley drive, a coupling, allowing the portable inspection of rotating equipment. So a range to meet various requirements, various flash rates, but a good preventative maintenance technique to help optimise your operations. Temperature control is always a good method of establishing machine condition or trending machine condition. So a new range of upgraded infrared thermometers from SKF, simple operation, good menus for fast and easy inspection, ergonomic and very robust design for usage in industrial environments, very high accuracy, very fast, with multiple lasers for easy targeting. So basically excellent machines for field usage. The use of endoscopes with various tubes, so this enables potentially the internal inspection of machines, maybe gearboxes or such machines. This is a case study for a snack food producer whereby they were having product failures, and when they had a product failure, they had to inspect the machine quite closely to see whether there had been any contamination of the food lines. So we worked with the customer and introduced endoscopes. This enabled them to do inspections without removing inline equipment, guarding, etc. They were actually previously stopping assets on average about 12 times a year and taking on an average 2 hours for each stoppage to check the machine, so production was stopped. So the value of using the endoscope was eliminating, in many cases, the need to remove guards and inline equipment, removing these 12 incidences taking 2 hours, and that time was reduced to about half an hour. So savings just purely in terms of the availability of the asset of £20,000 sterling every year. Oil checks. We have typically production plants, a lot of gearboxes or shaft-mounted gearboxes, maybe other gearboxes. Typically, to check the oil, we take samples, send them away to third parties for checking on condition, which can be expensive. So this device is an ability to check the condition of your used oil against a brand new sample. So it's a comparative device calibrated with new oil and then checked against a used sample, measures the dielectric constant or the amount of contamination in the oil. So this would be ideal for trending oil. And when perhaps the reading gets into the yellow or red, then you can send the sample away for inspection, significantly reducing cost of oil sampling potentially. And finally, dismounting. Well, why is dismounting important? Well, for safety purposes, for the speed of doing it, because an asset is unavailable while you're doing the dismounting and then the remounting process. You don't want to damage adjacent housings or shafts because they would then have to be repaired, introducing more cost and taking more time. Sometimes you don't want to damage the bearing. On larger machines, you might sometimes want to dismount the damage with the intention of remanufacturing or repairing the bearing, which is often used today. And again, as with mounting, we have mechanical hydraulically assisted, or the application of heat to dismount bearings. Wide range of pullers for all sorts of applications, external pulling, internal pulling, even blind hole pulling, so that they're easy to use, user-friendly, ergonomic designs. They reduce the risk of damage to associated equipment, sturdy, robust designs, as you would understand the need in the dismounting process. I would draw your attention at this point as well to skf.com/mount. So this is a free to access online tool whereby you can access it, input a bearing reference, and it will give you a full procedure for both the mounting and the dismounting of the bearing, along with links to the correct tooling that should be used in this process as well. Many users and technicians really like that, and this is printable. So many people will print this off and literally use it as a standard job plan for the mounting or the dismounting of the bearing. We're recently starting to introduce this also in an app form. so it can be taken to the job on a mobile phone, for example, or a tablet. It's SKF Bearing Assist. So literally, it has a facility that you can read the barcode off an SKF bearing box. You can input a bearing reference into the app, and whilst you're at the job, it will give you the mounting procedure, it will give you information about the bearing, and many more helpful aids to the recording of the mounting procedure and the sharing of the mounting procedure with colleagues as well. So I urge you to follow the link in this material to take a closer look at Bearing Assist as well. So as you've said, external pull, internal pull, some things you need to consider when you're looking at what puller to use, the width of grip that might be required, the effective arm length that might be required, and the amount of withdrawal force that might be required. A range of different types of pullers available in kits as well, available to you from SKF. For an external pull, these are typically arm pullers. Again, the image to the right there shows you an ergonomic design where there's a spring, so you can extend the legs, offer them over the bearing, release the spring, and it closes the leg behind the bearing. These can be hydraulically assisted to significantly increase the mounting force without the need for the mechanical actions as well. If you have access to the bore of the bearing but not the outside diameter of the bearing, there are other kits available to you. So this one features a collet, so this can be inserted through the inner ring of the bearing to behind the bearing. It's then expanded, so through impact you can pull the bearing out of a hole if you have access to the bore of the bearing. And if the bearing is completely blind, even there are kits whereby on the right hand side here you can offer the legs of the kit up to fit into the groove of standard bearings, and then pull against the groove in a deep groove ball bearing. If you require a longer reach or maybe a greater force, and you can remove parts of the cage, the mechanism to the left-hand side, the puller to the left-hand side, enables you to do that over a longer extension and applying more force to the bearing as well. So a range of different kits, even for blind hole pullers. So in conclusion, I hope that's given you a good insight as to the life cycle of a bearing, to maximise the life cycle of a bearing, enabling you to reduce costs and improve efficiencies in your plant. There are a number of technical support available to you. So here there are links to the SKF Maintenance Product Technical Support cage. There's the link to the skfdom.com/mount desktop aid, and also some information about the app, the SKF Bearing Assist app as well. So that concludes the presentation from me today. Thank you very much for your time and for joining us in these knowledge webinars. And I will hand you back over to Ringo for some conclusion, and also if there are any questions that have been posed during this webinar as well. So Ringo, back over to you.
Okay, thank you very much, Dave. Yes, really happy with this presentation. Thank you for that. And I have one question coming from Matthew, who asks something about the oil monitoring device you have. Is this for a particular oil type, or can it be used for all types, gearbox oil, hydraulic oils, etc.?
Yeah, that's a good question, and it can be used for all types because it's a comparative device. So with the device, what would happen? You would put a new oil sample into the reception point. You would then calibrate the instrument against that new sample, clean it, put a used oil sample in. It would give you a comparative condition between used and new. So pretty well any oil can be used and compared using that particular device.
Okay, thank you. How much grease should be applied as adequate?
So that's a very difficult question, and one where we probably need to have a bit of an understanding of the condition, the operating conditions that the bearing's running under. But just as a bit of a guide, I mean, the bearing itself should always be completely filled with grease. It's very, very important to get lubricant to every contact point within the bearing as early in its rotational life as possible. And the bearing, by its very nature, as it starts to rotate, will purge oil from its internal area. So it will push grease out of the bearing relatively quickly. So the bearing itself should normally on the mounting process be filled with grease. But what is really key is the amount of grease that you put around the bearing. For very slow rotating applications, you can quite often sort of 2/3, even completely fill the space around the bearing, the housing space around the bearing. If it's of moderate speed, we recommend sort of 20 to 40% of the housing space around the bearing be filled. And if it's a very fast speed application, we often recommend that the housing space around the bearing is left completely empty, because it's very important that the bearing can purge the excess grease as quickly as possible in fast moving applications. But Bearing Assist and skf.com/mount will give you some further information on the amount of grease and how you should be both initially lubricating the bearing during the procedure as well, Ringo.
Okay, thank you, Dave. And there is one more last question about the information electronically about the new System 24 connection unit. Okay, I will take care of that. I will make a note and take care, Matthew, that I will send you this information electronically. And there is another question. Is it okay to heat sealed bearings for mounting?
It is okay to heat sealed bearings to mounting. I mean, if you purchase an SKF induction heater, the default setting in terms of the temperature will be 120 degrees centigrade. And that really is a maximum for sealed bearings. If you go beyond that, then you have the potential to cause problems with the grease within the bearing and also the nitrile rubber material of the seal itself. So 120 degrees is a maximum. Normally, if you're mounting a bearing under normal circumstances, you shouldn't need to heat it to any more than sort of 70, 80 degrees centigrade. So that would be a typical setting that I would use if I was mounting a bearing. But you can absolutely heat a sealed bearing using an SKF induction heater. But again, just remember that temperature of about 120 degrees C is an important maximum for most bearings, to be honest, not just sealed bearings.
Okay. Okay, no more questions in the chat box at the moment. So I would like to tell you, everyone, that we will send out the handouts of this presentation later today, together with the recordings. As you may have noticed, we have recorded this session, so it's possible for you to listen to Dave's presentation again, or even share it with your colleagues if they want to listen to it as well. And the last thing I would like kindly ask you is to fill in the survey that we have sent out last Tuesday. Here we have asked to give us feedback on the webinar program we did the last couple of months. For us, it's very important in this digital era that we have to improve, and where we can even better listen to your needs. And for the period after the summer, we will definitely come up with a new webinar program, and all your feedback is more than welcome, so we can help you as much as possible. Okay, for now, thank you very much, Dave, again for your presentation. Thank you, everyone, for joining us today. This was our last webinar for the summer break. Hopefully, we will see you back after the summer. Until then, stay safe and have a nice holidays, and hopefully we'll meet next time. Thank you very much, and goodbye.